All right, hello Oak Hill. Happy day 3 of at-home learning. It's a great day to be a mathematician. We get to learn about adding and subtracting radicals today. So, actually not too difficult of a topic. Shouldn't be too bad today. First thing you need to know is what are like radicals. So like radicals have the same roots attached to them. So they have to have the same index and the same radicand, the number inside of the radical. So we're going to look at examples like that. It's very simple. You think of it as like, x's. So this says 4 square roots of 5 plus 3 square roots of 5. It's the same as thinking of it as what's 4x plus 3x. So that would be 7x. So 4 square roots of 5 plus 3 square roots of 5 would be 7 square roots of 5. So notice the radical doesn't change. You just do what the coefficients say. On number 2 here, we have the square root of 10 minus 6 square roots of 10. So much like x's, if this was x minus 6x, you might think of this as the understood 1 in front. So 1 square root of 10 minus 6 square roots of 10 is negative 5 square roots of 10. And again, that's not going to simplify any further, and the radical stays the same. On number 3, we look and notice this cube root of 5 is not a like radical with the 2 cube roots of 7s. So this one's going to stay separate. These two are going to be able to be combined. You might put the understood 1 in front of those. So 1 cube root of 7 plus another cube root of 7 would be 2 cube roots of 7. And then that 4 cube roots of 5 just tags along for the ride. It's not a like radical. On number 4, 2 square roots of 6 plus 2 cube roots of 6. Remember, to be alike, they have to have the same index as well. These do not have the same index, so this cannot be simplified further. It's already combined as much as it can be. Okay, so those are pretty easy examples. We're going to bump it up one notch, and this is going to be as hard as it gets today, which isn't going to be too difficult. So at first glance, some expressions look like they cannot be simplified further because radicands are different. However, if you simplify using the product rule, further simplification might be possible. So it's saying, look at your radicals. Is there a perfect square that divides it? And then in that case, do they become like radicals to where you can put them together? So we're going to be thinking about what we were doing yesterday, simplifying these radicals, and then combining like radicals from there. So let's look. What perfect square divides 50? 25. 25 times 2 is 50, so the square root of 25 times the square root of 2 is the same as the square root of 50. The square root of 25 is 5, so that simplifies to 5 square roots of 2. The square root of 8 is divisible by the square root of 4. 4 times 2 is 8, so that turns into the square root of 4 is 2 square roots of 2. Now you look at those radicals, and they are alike, so we're able to put them together to get a final answer of 7 square roots of 2. Not too difficult. Just one extra step from yesterday, right? We'll just do these examples. They're not going to take too long. It should be pretty short today. Square root of 12, you look at that, it's divisible by 4. 4 times 3 is 12. So we would have, don't forget the 7 out front, so that's going to be 7 times 2 square roots of 3, which is 14 square roots of 3 when you simplify that one. The square root of 75 is divisible by 25. 25 times 3, so that's going to simplify to 5 square roots of 3. We're able to put those together now. 14 minus 5 is 9, so 9 square roots of 3. Number 3, just a few more radicals this time. We'll just simplify each of them. Square root of 25 is a perfect square, so it simplifies just to 5. The square root of 27 is divisible by 9. 9 times 3, so that's going to be 3 square roots of 3. 2 square roots of 18, that's divisible by 9. 9 times 2, so that's going to be 2 times 3 square roots of 2, which is end up going to be 6 square roots of 2. Square root of 16 is 4. All right, so I've done all this work. I've simplified everything. Now I'm just going to rewrite it all with my minus signs in between. So I've got 5 minus 3 square roots of 3 minus 6 square roots of 2 minus 4. So we look at those, And there's only two things that are going to combine, the first and the last one, the 5 and the minus 4. That's the only thing that's going to go together. 5 minus 4 is 1. And then the other things are just going to kind of tag along since they are not like radicals. This one's a square root of 3, this one's a square root of 2, so they cannot go together. So that's as simplified as our answer is going to get. 1 minus 3 square roots of 3 minus 6 square roots of 2. We'll move on to number 4. What perfect square divides 98? And it's 49 times 2 is 98, so that's going to be 7 square roots of 2. Square root of 8 is divisible by 4. 4 times 2, so that's going to be 5 times 2 square roots of 2, so that's 10 square roots of 2. So I've got 7 square roots of 2 minus 10 square roots of 2 is negative 3 square roots of 2. So you can see these aren't too difficult. I think we have a couple more examples on the back. Yeah, we're going to add some exponents in there. So we've done these before already too. Again, we're going to simplify what we can and then put together what we can. Looking at this, remember you're dividing by the index, right? So these understood indices are 2. So what's 2 divided by 2? 1. So it's going to be 2x to the first. The 2 is just tagging along. The square root of x squared is, of course, x. Here, we'll simplify each of these pieces. The square root of 25 and then the square root of x to the 5th, right? So the square root of 25 is clearly 5. And then what's 5 divided by 2? That would be 2 with a remainder of 1, right? So remember, this first number represents the exponents outside of the radical. The remainder represents the number of exponents inside of the radical. So that's going to be 5x squared with the square root of x. And then I'm going to rewrite that 2x and put that minus sign there. Okay, this one, again, I'm dividing by 2. 5 divided by the understood 2 is 2, remainder 1 once again. So that's going to be x squared for my number outside, and the remainder is the one inside. X to the first inside, you don't need the first. Okay, now we look at that, and which of these are like terms? The second and third, those are like terms because they're both square roots of x, right? And they're both x squareds as well. So we have negative 5x squared plus the understood 1x squared is going to be negative 4x squared square roots of x. Notice variables don't change, radicals don't change. You're just doing what the coefficients say. Don't forget to put that 2x out front, and that's going to be our final answer there. Number 6 is pretty similar. You can pause the video here if you want, or you can just follow along, whichever you prefer. I'm going to start with my division. Remember, my understood index on a square root is 2, so I'm going to take 3 and divide it by 2. That would be 1 with a remainder of 1. So that's going to be x with the remainder of x. That one I cannot simplify any further, so it gets rewritten. And what's the square root of x squared? Clearly, that's just plain old x. So which of these are like terms? The first and second. I'm going to put the 3x first because that's, if it doesn't have a radical, I guess it's more important, so it goes first. We're going to put those two together. 1x minus 8x is negative 7x, square roots of x. Again, variables don't change and the radical does not change either. And that's going to be as far along as we can take it. We cannot put the 3x and the 7x together because this one has a square root of x attached to it. Okay, just a couple more examples. This time we're doing some cube roots. So if you remember from yesterday, you're just looking for what perfect cube divides this time. So what perfect cube divides 16? You would say that's 8, the cube root of 8 times the cube root of 2. And then I also have that cube root of x cubed as well, and the 5 out front too. So lots of things going on there. We'll simplify what we can. The cube root of 8 is 2. The cube root of x cubed is x, so that's all going to turn into 5 times 2x cube roots of 2. And we can do that multiplication. 5 times 2 is 10, so 10x cube roots of 2 for the first term. Second term, what perfect cube divides 54? It's going to be 27 times 2. And then I've got the cube root of x cubed once again. So I'm going to simplify the perfect cube parts. That would be these two. Cube root of 27 is 3. Cube root of x cubed is x. And then I've got that cube root of 2 tagging along. There was a minus sign, so I need the minus sign in between the two problems. Are these like terms? Yes, they're both cube roots of 2, so I'm able to put those together. 10x minus 3x is 7x. So 7x cube roots of 2. And that's as hard as it's going to get. That's the toughest type of problem you'll see. Number 8 is the last one. Again, a great time to pause the video and try it on your own and see if you can get the correct answer here. So again, we're looking, what perfect cubes divide these? What perfect cube divides 81? And that would be 27. So I'm going to rewrite it as the cube root of 27 times 3. 27 times 3 is 81. And I also have the cube root of 6 and the 4 out front. So I'm going to simplify the perfect cubes. That would be the cube root of 27 and the cube root of x to the 6th. So the cube root of 27 is 3. And I'm going to do this one. 6 divided by 3 is 2. So that's going to be x to the 2nd. Remember, that's representing my exponent. 6 divided by 3 is 2 for the exponent. And then the cube root of 3 will tag along. I can do that multiplication just like I could on 7. 4 times 3 is 12. So I have 12x squared cube roots of 3. That's a mouthful. Second term, again, what perfect cube divides it? That would be 8. 8 times 3 is 24. And then I've got that cube root of x to the 6th once again. So doing it piece by piece that are perfect cubes would be, again, those two. The cube root of 8 is 2. The cube root of x to the 6th is x squared. And then I've got the cube root of 3 that tags along. Minus sign in between, look. Are those like terms? Yes. What's 12x squared minus 2x squared? That would be 10x squared. So the cube root of 3 would tag along. And that's going to be your final answer there. It's kind of a weird looking answer with those exponents and indices next to each other, but that's the way it is. Again, please reach out to me if you need any help. Good luck on your assignment on my math lab.